Hi guys, it's the day 2 notes of Unit 1, and we're going to be talking about segments and angles and a bunch of the different properties they have. So the very first thing that the notes reference is what's the difference between AB with the bar over it versus AB without the bar. Right? So notation is something that we'll focus on a bit this year, but what the AB with the little bar over the top of it, which we'd refer to as line segment AB, that's talking about the physical line segment. All right, so if we actually had like a segment here, you're referencing the physical line segment. Whereas when you take the bar off of it, it doesn't mean you're not talking about the segment anymore, but it means you're referencing the measure of the segment. Right? So is the length or the measure of the line segment. So like as an example, here's where you could say AB is, 4 centimeters or something along those lines. That's the difference. So when we're going to put a number to it, we'll take the bar off the top. All right, so let's actually show where we can use this. So segment addition postulate. So you can have little points on here. And if we're saying that we have segment A, B, C, then what should be true is if I take the length from A to B and add it to the length from B to C, it should be equivalent to the entire length from A to C. All right, so you're just simply adding up these little segments. Why it's called a postulate. You're going to see that word pop up every now and again. It just means it's a statement that we accept to be true. Meaning it's kind of basic enough that we don't have to prove it. We can just all agree that, yeah, that makes sense. If I add this little piece and this little piece together, I should get the whole darn thing. Easy. So that's referred to as the segment addition postulate. So let's put it to use. So for each of these, we're going to want to draw a picture. So I'm going to put a little sidebar over here. We're going to want to draw a little picture, label the parts that are being given, and then the goal is to set up an equation. And then, of course, finally, make sure that you can answer the question. All right, so when it says E is between D and F, DE is 3x minus 1, EF is 13, and DF is 6x. Find DF. Without having a diagram, it's a little confusing. So you really want to read it first and then figure out, okay, how do I draw this? So when we say E is between D and F, they're implying it's between D and F on a segment. So just like this. So draw yourself a segment. Don't overthink it. If E is between them, put E somewhere between, and then D and F can go to the endpoints. Don't worry if it's not directly in the middle because you have no idea if it's in the middle or not. So just plop it on there somewhere. All right, now let's label it. So when we label, DE is 3x minus 1, EF is 13, and then DF. So I like using the little curly bracket. If that's tough for you to do, just use like a straight bracket maybe there, and label DF as 6x. All right. To find the length of DF, we next need to set up an equation. So using the segment addition postulate, it's the idea that if we add segment DE plus EF, we'll get the whole thing. So 3x minus 1 plus 13 should be equal to 6x. Easy. And now when I say set up the equation, of course, we mean solve it. So let's move some things around. So we can subtract 3x. We can combine these two so that we get 12. And we land at x equals 4. The last thing, it is important. You want to make sure you actually answer the question. So it asks you to find DF. That's the whole length. So you could plug in here and add them, or I could plug directly into the 6x. So DF is 6 times 4, or 24. And because no unit of measure was given, oops, sorry, I'm a little off the page there. You don't have to worry about it. Just simply leave it as 24, and that's perfectly fine. All right, let's jump to some angles. So before we talk about the measurements of angles, how to name them, right? You've seen a bunch of this probably from middle school and from Algebra 1. You can name The letter a couple different ways. Now, there is actually a letter in the corner here. It might be hard to read on your paper. There's an R. Maybe I'll put it here so you can see it better. There's an R right there at that corner, right? And that is referred to as the vertex of the angle. So ways that we can label this angle, we can trace it out and we can label it as angle SRT. So SRT, like we're literally tracing our pen on the paper. You could label it in the opposite order. We could go TRS. But keep in mind the R, the vertex has to go in the center, all right? So that means if it's the only angle there, we could actually just refer to it by the letter at the vertex. So angle R, or in this case, there is a number on the interior there of the angle. We could refer to it as angle 1. And we'll actually do that a lot later in the year to kind of save us having to write out all the letters. We'll refer to an angle on the interior often. So interior, exterior, the rest should be pretty basic to understand there. All right, when you flip it on over, there's a little practice referencing back to information from the first day, and that is with question 2 here. It says, name both pairs of vertical angles. So vertical angles, those are the ones across from each other. So we've got the pair at the top and the bottom, and then we've got the pair on the 2 sides. And I'm using a single swipe to show the top and bottom pair, double swipe just to show that they are equal measure, because that's the key. So when it says name the pairs, I can't call them angle B. There's too many angles going on. So I need to use the 3 letters in this case. So I can say ABE, and then angle DBC. That would be the top and bottom. And then the sides, angle ABD and angle EBC. Now, could we have really shortcut and put the numbers 1, 2, 3, and 4 in here and use those? Yep, and we'll do that often. For this part, though, since we got stuck with the letters, it makes it a little easier. Since ABE is 152 degrees, so that's the one at the top here, it says find all the other angles. Well, let's just label it right on the picture. Its vertical angle is always going to be equal to it. And then as for the other 2, if we look at the fact that these 2 angles next to each other make a nice straight line, that means they also have to add up to 180 degrees. And so to find this angle, I can set up an equation like saying x plus 152 equals 180. Excuse me. Or I can simply go right to 180 minus 152, and I can get that measure of 28 degrees. So there's a couple different ways. You don't always have to formally set up an equation. But with that being said, we used a property that I'm sort of assuming that you know already, and that is to do with the types of angles you could have. Acute angles, right angles, obtuse, or straight. So acute means we're between 0 and 90, right angle dead on at 90 degrees, obtuse between 90 and 180, or a straight angle, which measures 180 degrees like what we looked at just above. If it is greater than 180, that's called a reflex angle. So fun little fact there. Oops, sorry, I'm off the page there. That's if it's greater than 180. All right, so let's talk about the segment addition postulate, but now in terms of angles, so it's called the angle addition postulate. Same concept, just as simple as if we add up the angles, we'll get the whole thing. So if I add up these 2 smaller angles, they should add to that one big angle. So it's the general idea that the sum of the parts equals the whole thing, all right? So in this case, how would we show it? Well, the top angle is DBC. And to show that we're talking about the measure, we use an M. So the measure of angle DBC plus the measure of angle ABC is equal to DBA. Now, something to keep in mind, if you were looking at the angle and thinking this is angle CBA and I wrote ABC, we're both right. So don't get caught up in how to state the angle as long as it's a correct way to do it. B should be in the center for both because B is the vertex for both. Same thing down here. As long as that's true, then you're probably good to go. All right, let's use the property. This first one, it's actually a lot quicker than it might seem, but let's read the details first. So it says point Y is in the interior of angle XWZ. If the measure of angle XWZ is 121 degrees and measure of angle XWY is 59, find the measure of angle YWZ. Again, without seeing it, it's really hard to figure out what's going on. But if you think about what they're telling you, there's some point in the middle of this angle. They actually tell us the measure of that angle, and it's obtuse. So when you go to sketch it, you can sketch it as an obtuse angle. Now, if you drew it before you realize that, it's not a big deal. But otherwise, XWZ means X is out here, W the vertex, Z over here. All right, it's 121 degrees. So that whole angle is 121. And now it tells us point Y is in the interior. So somewhere here is point Y. So maybe just pick a spot, call that point Y, and then extend a ray through that point. Then it says the measure of angle XWY. So let's trace. XWY. So this angle here is 59 degrees. And then it's asking us for the measure of angle YWZ. So YWZ is this angle next to it over here. This is what we want. So you have a choice. You can simply label that X and create an equation. So X plus 59 equals 121. Or you can just go straight to saying, hey, if the whole thing's 121, let's subtract 59. Either way, you're going to get to your answer. So it should land us at 62 degrees. All right. Let's keep moving. On to the next page. Same concept, a little bit more work. We've got point T. Oops, there we go. Point T is in the interior of PQR. The measure of PQR, this time they give us an expression, 10x minus 7 degrees. RQT, 5x degrees, and then PQT, 4x plus 6 degrees. Find PQR. So we really don't know, is it acute, is it obtuse, is it right? If we don't know, then you draw it any way you like. So you can draw it obtuse or you can draw it acute. Maybe just for space's sake, I'll draw it obtuse. And then it says, let's see, point T is in the interior of PQR. So I'm going to make this PQR, and I'll put point T here. And let's extend. All right, let's get to the labeling step. PQR, so the whole thing, 10x minus 7. RQT is 5x. And then PQT is 4x plus 6. Right. We know the two smaller parts. We know the whole thing. This is perfectly set up for angle addition postulate. So add the two smaller angles, 4x plus 6 plus 5x, and then set it equal to 10x minus 7. All right, I want you to finish this one on your own, and don't be surprised if the post question references this guy. So make sure that you finish it. Okay. All right, we have another concept to talk about, and that is adjacent angles. So I'm going to slide this on up a little bit. Ooh, there we go. So adjacent, kind of a fancy way of saying next to. Now it's more specific than that, so let's talk about the specifics. We can say two angles are adjacent if they have a common vertex, a common side, but no common interior points. So keep in mind, I know I write quickly. If you need to pause the video at any moment or back it up and rewatch it, do that, right? So they have the same vertex, they have a side that they share, but no interior points, just meaning they don't overlap. So when you look at this next part, it just says determine if they're adjacent or not. I want you questioning those three things. So I'm going to slide up so you can see this here. So the first one, common vertex. Yep. a common side, if I trace this angle out and I trace this angle out, notice how I trace over that middle line twice. So that would be referred to as my common side. Here would be my common vertex. And then no common interior points. So like all the points in here are not the same as the points in here. That is a perfect example of adjacent angles. So I want you to take a look at all of these and determine, what do you think? Adjacent or not adjacent? So for part B, if I trace it, what you should hopefully notice, they didn't have a common side. I didn't trace over the same side. So they do have a common vertex, but not a common side. So this should be not adjacent. And it does say explain why. So no common side. I think we're going to save the other two for class tomorrow. So C and D, hold off on those ones. And let's flip and look at just one last thing on the last page of the notes. All right, flip it on over onto page 7 there. And so for linear pair, oops, sorry, trying to find that great combination of zoomed in enough so that you can see it, but not so zoomed in that you can't read everything. Maybe I'll adjust that a little. There we go. All right, last thing, a linear pair. Look at the first 4 letters there. It's line. So a pair of adjacent angles that form a straight line. And so it helps sometimes to have a little drawing here. So think of 2 angles that form a straight line together. Would look something like this, which means they also have to be supplementary, meaning they add up to 180. So let's use this number 6, and that'll be our last example that we do here in the notes together. Let's see if I can zoom in just a touch. There we go. All right. So it says, use the diagram to answer the following. Name a pair of adjacent angles that are adjacent and form a linear pair. So know that there's a lot of answers you could go with here. So one thing that sometimes helps is to trace your pen or pencil along one straight line and then look and see, okay, what are 2 angles that if I put them together would create that line? So actually, instead of looking at the top, if I look at the bottom, this angle here and the one next to it together would form that straight line. So that's an example that we could use. So that would be QPU and angle UPT. The next one, name a pair of angles that are adjacent but do not form a linear pair. So 2 angles next to each other that don't create a straight line together. You got lots to pick from. Sometimes the ones that people's eyes go to are these 2 over here on the side. So angle SPT and then angle TPU. So those 2 would be an example that you could choose. And then name a pair of angles that are not adjacent. So they can't share a common side. So I could say like angle QPR, and then anything that doesn't share PR or QP. So maybe SPT, and that would work well. Oops, right there. Now, are those the only answers? No way, there's tons. So we'll probably talk a little bit more about that the next time I see you in class. As for 7 and 8, we're gonna hold off on those in the moment. Make sure once you finish the video to answer the question in Google Classroom so that you get credit for completing the notes. Have a good one, guys.